At Fictiv, we make parts, so we wondered, what if we designed our own product for a swag giveaway? I'm David Willson. I'm the technical content editor at Fictiv. We wanted to create a product that mechanical engineers and industrial designers could have on their desks at all times and keep in their pockets. So I started brainstorming and narrowing down concepts. Some of the favorites were a phone stand, a box cutter, and a multi-tool, so I figured I could design all of those in one, in a way that could show off our manufacturing chops for various processes. We wanted to showcase our injection molding capabilities, but I also wanted to show other methods like 3D printing for prototyping and CNC along the way. I started defining the scope, looking up existing products, and doing some hand sketching. Then I got into CAD using Onshape's free software and some initial DFM for the prototype. When I start a new product design, I always begin with a clean skeleton sketch, just the essential lines and dimensions that define the shape. It needs to be simple and easy to tweak, since everything else in the model is built off of it. Sometimes I'll add fillets early on to help visualize the form, but depending on the complexity, I might save them for later to keep things more flexible. I also like to create a reference sketch to account for mating parts. In this example, I modeled the thickness of an iPhone 16 Pro plus a typical case to make sure my design accommodates a realistic range of devices. It was challenging with this design to make sure it fits every possible case and accessory, but by adjusting angles and offsets, I was able to build in some clearance for thicker devices, while also accounting for thinner devices without cases. For primarily symmetric parts, it's best practice to model half of the part and mirror it across a midplane. I like to place the mirror feature later in the model tree. That way, I'm only updating one side when changes come up. In this design, the hinge thickness and pin diameter drive the mirror plane distance. Speaking of the hinge, I started with a circular sketch to define its size, which also determines the overall width of the product in its collapsed state. I split the hinge down the center and added clearance to account for tolerances. Our stack-up calculator really helped there, and I included a link to that resource in the description as well. Once that was dialed in, I cleaned up the edges for durability and manufacturability, especially if we go with molded parts. My initial design used a press fit pin for 3D printed parts, with an intention to use a snap fit feature in the production version. One of the last features I added was a box cutter edge. I tried a few placements and angles before settling on one that felt natural and safe. I tested the sharp edge with 3D prints, and while it works in the plastic part, it'll be far more effective once it's machined in metal. That's why I included a swept cut and a standard 10-degree chamfer in the design to prep it for a metal alloy version down the line. If you would design this differently, feel free to let me know in the comments.